Here is the second water pumping problem that I want to do for you. The container of water here is what I would call a trough. It's got a trapezoidal end on both ends. I'm saying that the short side of the trapezoid here is 2, the long side is 4, the height of the trapezoid is 1 foot, and the whole trough is 8 feet long. Okay. Actually, and I'm picturing this full of water, completely full, and this is the watering trough for my cows. So my cows are going to come in and drink all of the water out of the trough. And in drinking, they will lift the water up to through their, into their mouth, up through their throat. So the question is, how high does that get? And I'm saying it's probably about 3 feet off the ground where these cows get the water up to before it goes down into their stomachs and whatnot. Okay, so the top of the tank is at 1 foot high, and they're going to be lifting it 2 feet beyond that. Okay, all of the water. The thing is, like the last example, I have to slice this into horizontal pieces. And in this case, these horizontal pieces look like rectangles. The thing is, each slice gets lifted a different amount. And so I have to figure out its weight and then figure out how far it has to be lifted. Take the weight times the distance lifted, that's work done. Add them all up for every single one of these slices, you get the total work done. Okay? So in order to calculate the weight, I need to find the area, give it a little bit of thickness, dy here, or I don't have a variable yet, so I got to give it a little bit of thickness, and to get a little bit of volume, multiply the volume by the density to get weight, and then multiply that weight times the distance that's being lifted. So let's see. The little bit of area is going to be length times width. Well, every single one of these slices has a length 8. The thing that I don't know is how wide are they. So let's call that W. And at this stage, I need a coordinate system. And really, I just need a vertical coordinate system to keep track of. So I'm going to put a vertical line here and then make a decision where, how it's labeled. And various people do this different ways. In fact, I'll probably do this problem 2 ways. Let's start on this one. Let's say that y equals 0 down at the bottom and y equals 1 right here at the top. And then you're going all the way up to 2 past 1, so this must be y equals 3 way up there, right? So for each value of y between 0 and 1, I've got one of these slices. And what I want to know is for each value of y, how wide is the slice? Well, with all these straight lines going on here, I'm inclined to think that I can just draw a graph. If I put this y here and w there, I can see that when y is 0, the width has to be 2. And then when y is 1, the width has to be 4. So I need a line that will connect those 2 points together. Well, I can come up with an equation of a line pretty easy. The intercept is 2 here, so w equals 2 plus, what's the slope? I got a rise of 2 for a run of 1, so 2y. Just to double check, when y is 0, 0 times 2 plus 2, well, yep, that's 2. When y is 1, 1 times 2, that's 2 plus, 1 times 2 is 2, plus 2 is 4. Yep, I got up to 4. If you're in the middle there, halfway between 2 and 4, so when y is equal to half, plug a half in. Half times 2 is 1, plus 2 is 3. That's right. So it looks like the width is always 2 plus 2y. Okay. In the previous example, in the last video, the coordinate system was essentially imposed upon us because we assumed that the equation of a circle was x squared plus y squared equals 9. That meant we put that circle on a coordinate system already. Here, I had a choice. I put this coordinate system in and decided where 0 is. In fact, I'm going to do it again in a minute, and I'm going to put 0 in a different place and see that we still get the same answer. Anyway, with this arrangement, this is the area of each slice. If I then multiply that slice by a little bit of thickness, that little bit of thickness is an up and down thickness, which is the direction of my y-axis. So that's a dy thickness. I get a little bit of volume. If I take that volume now and multiply it by the density, I'm going to get a little bit of weight. Now, what's the density of water in pounds per cubic foot? Well, again, I'm not expecting you to remember this. I will give it to you on any problem that I ask you to do. I'm going to go with 62.4 as the density of the water. The water, what just happened? Density of water is different depending on, is it fresh water, is it salt water, is it, what's the temperature? But anyway, you see different numbers used. I'm going to use 62.4 as the density of water. Pounds per cubic foot. So that's pounds per cubic foot times cubic feet here. 2 plus 2y times 8 times dy. That would then be pounds. Now, how far does this weight need to be lifted? Well, each slab needs to be lifted a different amount, so this should depend on y. But whatever y you're at, you're trying to lift it all the way up to 3. So the distance lifted is the difference between whatever 3 is and whatever y is. Notice when y is equal to 0 down at the bottom, 3 minus 0 is 3, you've got to lift that a distance of 3. When y is equal to 1 up here at the top, 3 minus 1 is 2, so that's going to be lifted up 2. Okay, so that's the formula that's telling you how far each slice needs to be lifted. Now, in order to calculate work, I need to multiply the distance lifted times the weight and add them all up. So the work done is going to be the integral of 3 minus y times 62.4 times 8 times 2 plus 2y dy. And I need to say, where am I integrating to and from, or from and to? Where do I have the water to start with? The water, I got slabs of water everywhere between y equals 0 and y equals 1. Okay? And when I do that integral, I get 3,660.8 foot-pounds. Now, I want to set this up a little bit differently and see that I get a slightly different integral, but that it gives me the same result. Okay? So let's very quickly do this. I'll redraw this thing here. This time, I'm going to still have a vertical axis here, but I'm going to put y equals 0 at the top of the water and put y equals 1 down here. So this would be y equals, that feels funny to me. I mean, I could do it, but let's put y equals 0 clear up there. Put y equals 0 clear up there. So this would be y equals 2 and y equals 3 down here. Okay. Pick a coordinate system. The thing is now, each slab, it's still the same setup. Each slab looks like that. The width is, now I need to recompute what the width is, because for each value of y, well, between 2 and 3, I got to figure out what this is. So now I'm looking at this thing saying y width, when y is 2, the width is 4. And when y is 3, the width is 2, right? So now I'm trying to get the equation of that. And I can get the equation of a line. I gotta be a little careful here because y is usually my output, and now it's the input. So I'm thinking point slope form, because I don't readily see, oh, maybe I could see the intercept pretty easy. Actually, let's do that. This for every 1 I go this way, it goes up 2. So if I go 1 more, it should go up to 6, and if I go 1 more, it should go up to 8. So it looks like the intercept there is at 8. So this would be w equals 8 minus, the slope is negative. In fact, the slope is negative 2y. So the little bit of area is 8 minus 2y times, this is still 8 deep, times 8. Right? Just want to do a quick double check here. When I plug a 2 in there, this is 8 minus 4. Well, 8 minus 4 is 4, so that's the width at the top. That's what I wanted. When I plug a 3 in here, this is 8 minus 6, which is 2, which was the width at the bottom. So that's a good function telling me those widths. A little bit of volume then is the 8 minus 2y times 8 dy. a little bit of weight is 8 minus 2y times 8 times the times the density of the water, which is 62.4. And the distance lifted now, well, with it set up this way, y is actually the distance that you need to lift. That is, when y is equal to 2, this slab at the top gets lifted a distance of 2. When y is down here at 3, the distance that this slab down at the bottom gets lifted would be 3. So y is actually how far that particular slab has to be lifted. So then the work done here, total work, equals the distance lifted, or an integral of the distance lifted, times the weight, and the weight is 62.4 times 8 times, what is this, 8 minus 2y dy. And where do I have the water? Well, in this example, I have the water between 2 and 4. This definitely looks different than that integral we had up there. There's pieces of it that are similar, of course, the 62.4 and the 8, but it's a different formula for how far you need to lift. It's a different formula for the width of the thing, and it's different in limits of integration. And yet, when you type that into your calculator and say, give me the value, it says, oh, it's equal to 3,660.8. Okay. In doing these problems, you're going to need a vertical axis. You have the choice of labeling that vertical axis the way you want. The first example, I chose to have y equals 0 at the bottom and y equals 3 at the top. The second one, I did y equals 0 at the top and 3 at the bottom, and yet I got two different looking integrals, but the value was the same. The amount of work done calculated was the same. Okay. You need to try a bunch of these, ask your questions in the forum, and we will answer as many as we possibly can.